Hi. So now let us discuss about the exception handling in Python. So generally there are two types of errors will take place in Python. So we can say that it's a static error and also we can say the late errors. We can say it as a runtime errors. There are the static errors are basically the kind of the syntax errors which can be easily handled by the compilers. Whereas this runtime errors will happen during the execution of the program. So it is always we need to have a good mechanism to handle these kind of exceptions. Otherwise, the program will get terminated abruptly. So we use a mechanism separately here for handling the exception called exception handling mechanisms, which involves in four important tasks. So the first one is hit an exception, and the second one is throw an exception, and the third one is catch an exception, and the fourth one is handle an exceptions. So these are the four important steps that we use in exception handling mechanism, which is very much similar to the exception handling mechanisms in C++ and Java as well. Even in the C++ and Java also, we use the same four steps for handling the exceptions. So here in Python, there are exception classes are defined for some of the exceptions. So we have the common exceptions as defined as a class. One is called the very basic exception, which is called exception itself. And there is a class called attribute error, end of file error, in-out error, index error, key error, keyboard interrupt, name error, stop iteration, type error, value error, and also we have a zero division error. So whenever we use this class, and if particular exception is raised, and if the particular exception is hit, then the corresponding the object will be raised here. So now if you look into it, the exception is a base class for the most of the type errors. For attribute error, it raised by the syntax where we try to access the a data member of an object. If it is not there, then it will throw an error. So that's an exception. And the end of file error reached for console or file input whenever it is reaching the end of the file, so it will raise an error. So like this, we can easily handle the exceptions by using the predefined classes. Very importantly, we can also have a zero division error as well. So it is raised when a division operator used with zero as a divisor. So now here, let us take some understanding about how to raise an exception. No, it's called generally we say throwing an exception. When the exception is hit, the next thing is what we have to do. We have to throw an exception. So in order to throw an exception, we follow small syntax here. That is raise. Raise is the construct that helps us to throw an exception, and followed by what type of an exception. So it's a value error. As we know from the previous slide, it's a value error could be the exception. And within bracket, we can specify the remarks, the comment about this exception. So we can say that n is a negative number. N is a negative number. So when the error is thrown, it will no, it will show that on the screen. N is a negative number. It's a value error. And yes, let's see how to catch an exception using this simple program where we try to divide a number by 0. So whichever the part of the program you want to try, you enclose it in a try block. So using the appropriate indentation, we can put the sequence of statements inside the try block. So inside the try block, now we have the line number 2, we have the integer value which is obtained from by getting the input from the user, and that is stored in a, that's integer a. And similarly we get the integer number b. So we have two integers a and b on the uh, values, no, on the integer, on these variables, corresponding variables a and b. Then, uh, by chance, no, it depends on the condition how the user is going to give the value. So let's say, no, we have an equation where C is the division of the A and the B. That means the C will have the quotient of A divided by B. Now, when we try to print the C, we can use it by print it by using a print function. Now, let us assume that, no, as a programmer, let us assume that there could be some probable errors, right? So what are the probable errors? The probable errors could be we do not know what value the user will enter. We are asking the user to enter the dividend or divisor. So if user is entering any value other than the number, then that could be a value error. So this value error can be caught by using the keyword except. So except will catch the value error, and subsequently we have the print function to tell what is the no possible what is the no cause for an error, or we can also give a warning like enter a valid number. So whenever if the value error exception is occurring, it will print on the screen enter a valid number. Similarly, we can also have a zero division error. So whenever we try to divide an a by 0, whenever the divisor is 0, then no, you will get a mathematical error. So in order to avoid this, we can use the class zero division error, which is defined for an exception, and which in turn it will immediately catch that exception, no, because we are trying, no, as we're trying, it will automatically, it will find out the zero division error. So then when the zero division error is thrown, it will be caught by using this except zero division error. And it also we have a remark to say, yes, you are trying to divide a number by 0. So that information we can give it to the user. And also, no, here sometime we may get some kind of an error by chance if the C is not defined and you are trying to use, no, the C to we are trying to print the C, right? Sometimes, no, then it will give an error. There is no such, value C or such variable C. Then that would be a name error. So since we are trying inside this, right? So as many statements as we try, for everything there are possible exceptions, So in order to handle it, we can have a name error class. So the name error class will handle the such kind of exception, and it may print it on the screen that we know as a remark variable C is not declared. That is the case when the C is not declared previously. And also we can handle the exceptions using the objects, exceptions using objects. So here what we try to do, we try to uh, handle the exception called a value error. So we try the statement which gets the input from the user. So the line number 3 gets the value from the user and convert this into an integer value that is in turn stored into a variable A. Yes. So what we are attempting is we are trying to attempt a value error. And also it is not like a previous case. Now we are going to use the exception object. So if you want to use object in Python, we defined value error is a class, it's an exception class which we have seen earlier, and has an object E, as an object E. So E, as E. So as is a keyword that we use. So except value error as E. So now E is an object. So as an object, so this value error properties will also be there in E. So now all that what we are specifying here is in a just to have our understanding, we in the print function we just type the statement value error comma E. That means we are passing the entire exception object into this print function. So now, being a class of no exception, the value error itself, no, it having a handling mechanism. So it understands when there is a value error occurs, how to handle an exception. So now when we enter some number, no, while executing the program and enter some number, instead of that, if you give some character over here, then that's a value error. That's a value error. So for our convenience, we have defined, no, we have given a remark here. So if there is an exception is going to happen, that's going to be a kind of a value error. So value error is an exception that is expected. And also the remarks, we do not know what to write. So what we have done with the help of the exception object, which is derived from the value error class, it has a one mechanism to interpret and display the exception details. So it says that invalid literal for int with the base 10 SD. So it says that what is expected here is integer, but what is passed here is something like a character called SD. So which is, it is not a valid one, which is supposed to be a value, which is supposed to be an integer. So if you enter the integer value, then there will not be any exceptions. So like using the object, we can handle the exceptions. And also there is another important thing here, which is called no using a finally statement in exception handling. So when we have seen that earlier, when there is an exception and when the exception is thrown, it is caught and displays the details of the exception, and immediately the program gets terminated. So by chance, if you are looking for some no means where irrespective of the exceptions takes place, you need some statements to execute, then we can use the finally construct. Finally construct. So what we have done here, we are just trying the exceptions on these two statements, line number 3 and line number 4. In line number A, we have defined a list and a list of size 6, list of size 6, and having an index starting from 0 to 5, and the values are 5, 6, 7, 8, 2, 3. Now here, what I'm trying to do, now I want to just access a particular element of a list. So I give A of 6, A of 6. A is a list. I want to access the element at position 6. But now if you look into it, actually, we will not be having the index 6. So because the last index for the given list is going to be only 5. So that means there is an error. So when it trying for an exception, it gets an error called index error. So we throw an index error and through an object E, which we have seen earlier in the last slide as E, and now print for our convenient, we say index error caught, and we pass the the responsibility of displaying the details of exceptions to the object E. So we print the object E as well. So that is going to be printed. And finally, right, so exception is occurred, the program is supposed to get terminated, but we want some more work to be done. What is the work that I want to do? I just want to print the list. Okay, so if I, irrespective of the exception, if I want to print the, and if I want to do some operation, I can use this keyword a, finally, which is in the line number 8, finally. And now any statement enclosed by finally will definitely execute it for sure, irrespective of the exception. So finally, print a means it will print the list contents 5, 6, 7, 8, 2, 3. So we can use the finally also for our requirements for implementing any kind of applications where instead of exceptions, the statements has to be executed. Okay. Thank you.